Clear.
So please just unmute yourself and you can ask the question direct. And no, I will not leave the room. I will use another computer, so I will be with you. Yep. So please just ask the question, and we have Professor Angel, and we try to answer your question. And who would like to start?
Wait a second. I am logging on the course.
Mm-hmm.
I need a second.
Mm-hmm.
My first doubt was, how do we manage to the first one, because I didn't kind of get what was the main point of the fourth assignment. I went through all the documentation, and I didn't exactly understood how to do it. So let me log in, and then I can give you more details in what exactly I didn't understand. So, so for our fourth module, we had for big data and artificial intelligence, we had two presentations, one each one with different documentation available, but there was exactly no task required to do after the presentations. There were some tasks that you had to do. For example, you had to watch a specific video or a certain topic, or you had to read some article, but those kind of tasks were about 15 minutes or at most 20 minutes. So I actually did not know what was the main task that I had to do for the fourth module.
Mm-hmm.
Okay.
I don't know if you...
Yeah, I understand. Okay. So as I see the other question which was posted in the chat by Elena Olmos, you generally want us to explain the tasks again,
Mm-hmm.
and maybe give you a little bit more information. And what I will do also will demonstrate how the task is performed and what it has to be done. So is this okay? So I'll start, explain the assignment again.
Yeah.
Go task by task and demonstrate what was the idea, and how to solve it. Mm-hmm. Okay. So actually,
and maybe I can just ask the students, please interrupt us if there is something not clear during the explanation.
Mm-hmm. Yeah, of course.
Yep.
If you have any questions, just interrupt and write in chat, or ask through the meeting. It's not a problem. I'll stop and explain if something is not clear. So if we start, there are actually two tasks that are given in this module. The first task was given by me. It's actually assignment. The first assignment 1, was given by me, and assignment 2 is given by Associate Professor Fergan Feradov. So I'll just give you a brief overview on the two assignments. Then I will explain assignment 1, and then I will leave Fergan to explain assignment 2 because he did it. So those two assignments that we gave you are actually directed at the usage of artificial intelligence. So the idea behind those assignment was for you to see how artificial intelligence can be used to process data and how it can be used to give certain results from certain data. So in this specific example, we use general data. Cannot be said that it's big data. So the main accent of the assignments is artificial intelligence. The first assignment was done in Python script and uses the algorithm which is called random forest. I'll explain a little bit about it when I show the assignment. And this algorithm was used to do a regression and prediction. So the idea was for you to see how it's done in code. So if you're doing artificial intelligence, how it can be done in software in code. And the platform that was used for this was called Jupyter Notebook. It allows for a graphical presentation. This notebook actually contains the Python code with the necessary libraries that can implement the random forest algorithm. So I'll go with the assignment in a little bit. And the second assignment uses again artificial intelligence, but implemented through a specific tool. So the second assignment uses a tool called Veka, where you don't need to do a programming. You just specify the parameters of the algorithm, and the programming is already done in the tool. So those are the two assignments. First one demonstrates artificial intelligence, where the algorithm is coded using Python, so you can see it in code. While the second one uses artificial intelligence through a tool, through the tool Veka. And the main idea behind those two assignments is not for you to implement it or to write the code or to do the programming, but just to see how the artificial intelligence can be used in solving certain tasks. So I'll begin with assignment 1, which is the assignment that I gave. I will now share my screen. So do you see my screen? What do you see actually?
Yes, the
Yes, we
PDF.
see your screen. We see your screen.
Okay, it's the assignment, right? Right. Yeah. So the assignment is called example of implementing AI to predict air pollution index based on meteorological data and specific time of the year. So a little bit about the premise of this assignment. So usually air pollution depends on many factors, especially urban air pollution, as it's in the task. So if we extend the title a little bit, it's about urban air pollution, where the idea is to calculate the so-called air pollution index, which can give a quantifiable means of evaluating air pollution. So this index has several levels and divides air by quality, like very bad, bad, good, very good, and so on. And the idea behind this algorithm is to check if we can predict what the air pollution index would be based on weather and based on certain day of the month. So as I said, air pollution is connected to a lot of parameters, but it can be affected by weather. For example, in bad weather, for example, in high wind, we might have lower air pollution than still airflow in the city. For example, in high humidity, we usually have higher air pollution index. For example, when it rains, people use their cars more often, so the air pollution index is increased again. Same is with the days of the week. Usually, you would expect higher air pollution index during the week when there is a lot of traffic, and less during the weekends. At some cities, it can depend on the month specifically. So the idea of this is to use artificial intelligence to predict air pollution based on time of the month, day of the month, and specific weather data. And
sorry, before continuing, I have a question,
yeah,
because
sure.
I have not seen this document in the syllabus. Or I mean, through the documentation that was given to us in our webpage, I did not see this document, or yeah, I didn't even know that we would use Python programming language to actually compute an AI. I am a bit confused.
Yeah. So if you haven't seen the document, I'm
I'm sorry. I
asking
mean, I just
question.
went to I went to the web page of the course, and I did not realize this one on the documentation, so I was a bit confused.
So it's here. If you go to materials for module 4, here in the assignment field, assignment 1 is the document that explains this assignment, and assignment 2 is the document that explains the other assignment.
And excuse me, Justin, the third link that you can see under assignment 2, it is the files that are required in assignment 2. So you can directly download them. They are provided there. So that's the third link.
Yeah, so I will copy this in chat. Tamer already did. So thank you, Tamer.
Yeah, it's
So
already there.
you go to materials for module 4, big data and AI, and where you have assignment, it's the free files that are related to this assignment. So actually here you can read just a short introduction to what I said, and you have instructions how to implement the assignment, but without the instructions, I see that you did not understand. So if you don't have the instructions, it's almost impossible.
I just didn't know that there was this page that we could use. I mean, if I share my screen, you would see that in the syllabus that that I used and some of my friends have also used during this course. There is not, and this document is not located there, and I didn't know why.
Maybe something was missed, but now you have it, and I'll continue with explaining the task. As I said in the beginning, this code that I explained in short, so the algorithm that uses prediction for air pollution based on weather data and time of the month, this was realized in Python. And the algorithm that I used to realize this is called random forest. So I will not go in details about what random forest is. We might say that it's artificial intelligence algorithm that allows us to predict or make decisions based on previous data. So the idea is that we have some previous data where we have the weather and the air pollution index. And we use this data to teach the algorithm what is the connection between the input or the features and between the output or the decision or the prediction. So we use the data to teach the algorithm, and then the algorithm can make decisions based on this data. So it's a little bit random because the teaching process is random. So we might get slight deviations from repeating one training and second training. So it's a bit different every time we train the algorithm. But in reality, we can do this prediction using it. So for this assignment, I built the code necessary to implement this random forest in Python. And the problem, however, is that, for example, many of you might not have installed Python or don't have the proper packages, libraries, dependencies, things like that. So I used a tool which is called Jupyter Notebook, which can be hosted on specific servers, where I set the Python code. and you can load it and have everything pre-installed on the server. So you don't need to install any specific software, but you can use it from your browser. And this is explained in this startup instruction. So when you have the file, you follow the link, and the link will take you to this web page. It's called Binder. This is the place that the assignment is loaded from. And you have simple instructions how to get to the Jupyter Notebook. I already have it loaded on my computer. So if you follow the if you follow the instructions, you should get to this web page. So this is the Jupyter Notebook. The Jupyter Notebook allows us to combine actually HTML code with Python code. So this text here is actually the HTML, and these fields here are the Python code. And when we started, we can, as you see, we have specific cells. So the cells with the HTML code are just for instructions. Here you have additional instructions on the assignment and on what the different parts of the codes do. And here, if you click on the code, you see this one. It means that it's the first cell that is to be executed. You can run it with this button, and you can run each cell. You see one after another. And on specific, oh, just a second, maybe I need to reload this. Sorry, I will start it again. So after some time, the session expires. So you actually see the process. So when you click on the link, you have to wait for the repository to load or to start. So we will wait a little bit. There we go. So we just need to click here where it's assignment 1. This is given in the instructions. And now we can evaluate the cells like this. So some cells will give you an output. So for example, this cell here provides you with an output. So this output here, for example, is the header of the data. So this is just a small excerpt of the data we are using to train the algorithm. And here you can see the parameters date, month, date of week, average temperature, minimum temperature, maximum temperature, precipitation, wind speed, pressure. These are what we call features. This will be used to do the predictions. This is the input data. While this AQI is the air quality index. This is the result. So actually in the beginning, we feed the algorithm with features and results, which are real. I have taken them from several sources. You can check them in the assignment document. And based on this, we built the random forest algorithm. And this algorithm allows us to do predictions based on input data. So if we put certain data, we can do specific predictions with it. And for example, at the end, when we train the algorithm, so here the algorithm is already trained after this code of line. So it says the classifier is then trained. So here the classifier should already be trained. And when the classifier is trained, we can check its accuracy. So for this session, the accuracy of this classifier is 0.73, about 0.73. And here we can check the so-called feature importance. So the feature importance is how much each parameter that we provided to the algorithm contributes to the decision that the algorithm makes. And here, for example, you can see the different data that we gave the algorithm. the importance of the different data that we provided to the algorithm. So for example, if we come back here, oh, something is not okay here. Just a second, I'll maybe need to run it again. Okay. Maybe I missed some cell. So you can see here, for example, in this run, the most important parameter was the minimum temperature. So the minimum temperature gave the most effect on the prediction. Then we have day of the week, average temperature, and so on. So this means that we can say, if we go back and analyze it, you can say, okay, the day of the week is pretty important when predicting air pollution index. And this is actually relatable because if we have, as I said, weekdays, usually we have higher air pollution. When we have weekends, usually we have lower air pollution. So depends also on the specific city. Here you can do predictions by yourself by inputting different data. And this is an example that if we put specific data, we get specific output. So for example, here, I took the data from one of the lines and just inputted it to see if it will predict correctly. So this is how this algorithm operates. So you put weather data, you put day of the month, day of the week, and it will predict the air pollution quality based on this specific data. So what was given in the assignment? So
there's a question.
There's a question. How do you know that the minimum temperature indicator is important? Okay, if we go back here, these numbers you see here, they will sum to 1. So they should sum to 1. So if you get all this, they should sum to 1. So this means that indicators, features which have higher importance will have higher number. So, and features that will have lower importance will have lower number. For example, for this run, the average temperature has pretty low number. And this means that it is not so important to the algorithm. So the higher the number goes, the higher the importance is. So actually here in this run, the higher importance was given to the air pressure. So this I think also matters. In usually higher air pressures or lower air pressures, you can have changes in the air pollution index. So this is how we evaluate which is the most important parameter for the algorithm.
Maybe I ask a question again for that, Professor Angel. I don't know if Elena means these numbers here or she is leaning about the function behind producing this number. So if maybe I can get this opportunity just to let her, like this number is actually coming based on a function that the logarithm itself is based on.
Okay, so the idea behind this random forest algorithm is that we create the so-called decision trees. In decision trees, we have several levels of decisions. So for example, the algorithm trains itself to make this. Yeah, I'll explain the second question again. So the random forest algorithm is actually series of decision trees. Each decision tree, a simple decision tree can be like asking a question and you have yes, no, and then asking another question, again, yes, no. And based on these answers, you go to a result. And this is similar. So for example, you ask, is the average temperature bigger than this? Yes, no. Is it lower than this? Yes, no. And is it something like the other parameter? Is it bigger, lower, bigger, lower? And if you answer the questions, the algorithm says, oh, maybe it's the air quality will be good or bad. And this is the so-called decision tree. When we have a random forest encompasses a high number of decision trees. And in the end, the average results from these decision trees. And if you have asked the question, is the pressure something or something, too many times, this brings higher importance to this parameter because the decision trees make their decisions mostly on those parameters than any other. The thing with random forest is that in order to build it, we generate random trees. And by generating random trees, there is always the chance to have random results. So the implementation of the random forest is the same. So it will, if I run it again with the same data, I will show you. If I run this again, now you see it gave different results. So maybe you see, but before that, the pressure, the importance of the pressure was 0.3, now it's 0.33. So it will generate the trees randomly. So it shouldn't vary so much between the different parameters, but each training of this random forest will give different results. But because we average at the end, the prediction should be the same.
I will just in order to add, I will also to what Professor Marunov has said, I will also demonstrate in a couple of minutes and talk about feature selection. And just some algorithms are random or stochastic, and other are deterministic. So the difference is that, for example, for some algorithms, with when the input is fixed, the output is always fixed. So for fixed input, the output is always the same, while those are deterministic algorithms. And in other cases, like the random forest or neural networks, there are slight variations each time when you run the training. So such algorithms should be trained multiple times because in order to evaluate the difference in the results that they give. So is it statistically important or not? But in order to conclude it, some algorithms do that. Their result always varies with a fixed input. So random forest is one of those algorithms. The relevance will vary slightly in most cases. Again, this should be evaluated, how much it varies with each iteration. Although the input data is the same, whenever this algorithm is run, the numbers that you get as scores for the features will slightly vary. Yeah.
Okay. All right. Should I continue, or is it clear about the feature importance and why it's different sometimes and how it's calculated?
And again, I will. The second assignment is aimed exactly towards feature analysis. So I will go in a couple of minutes over these points again, and I will introduce some additional information on that as well.
Okay, so now the tasks that are given in this assignment. So the first task, view the CSV data files and the sources of the data and answer the following questions. Oh, sorry. view the CSV data files and the sources of the data and answer the following question. Is this application based on big data? So if you go here, you can see the sources. So these are the sources for the assignment. They're actually comma separated values with several different ones. So this is by no means big data. So if you have listened to the lectures of the big data, you probably can differentiate, but this is a simple table. So if I would say the answer to this question is no, this is not big data because it's just a structured data of one table. So next we have run the notebook for all the provided cities and record OBD accuracy and feature importance. So you already saw, just if you come back here, you already saw where the feature importance is. So it's here. And the OBD score, this is the accuracy that we achieved. So this algorithm has a procedure to be tested. So when it is tested, we take some of the data and use it to test or verify what we have completed. So here the accuracy of this test is 0.73, 0.73 means that 73% of the time it is right and the other 30 or 27 it is wrong. So here you can see the OBD score. Here you can see the feature importance. So I think you can easily complete this this task. If you want to change the city, you just need, it's explained in detail here. Yeah, it will vary, so it's not a problem. You just make one run and put whatever it comes, no problem. So in different cities, actually, it will give different results. So in order to change the city, you need to change the file that is being loaded. So the file is loaded from here, from this field. So if you want to do, for example, Vienna, you need to change the file name to Vienna, like this. So now it will run for the different database. And probably will give different results. So it should give different results. So in this way, you can check the data for each city and you can record your answers here. So the next task, try to provide explanation for different accuracy between different cities. Same algorithm, same settings. So this is pretty obvious. For example, if we come back here, the accuracy we get for Vienna and Varna was about 0.70 something. So for Varna was 0.73, here is 0.76. But for example, if I get New Delhi like this, and I run the code again, you see that I get accuracy 0.5. So my accuracy dropped from 0.7 to 0.5, and this is a very significant drop. So why is this? And this is asked in the assignment. So why is there a difference between the cities? So one cities we get high rate of predictions, the other give us low rate of prediction. This can be determined by checking the data. So if we come here and let's say check Vienna's data, we can see that air quality for each recorded date, so you can see it, is either good or moderate. So each recorded date has either good or either moderate. And the algorithm predicts more accurately between two outputs, good and moderate. And if you go to New Delhi, you can see that we have air quality ranging from hazardous, unhealthy, very unhealthy, at some time unhealthy for sensitive people, or moderate or good. So here we have 5 or 6 outputs. So for the first data for Vienna, we had 2 outputs. Here we have 6 outputs. So the lower accuracy is because it's very difficult for the algorithm to link the features to all these outputs. For the first one was okay because it was either good or moderate, but here we have large variation, and this means that the algorithm is not so effective, and that's why it provides lower accuracy. So this is task 3. Task 4, try to rationalize the feature importance, how the different features affect their pollution. So here it was this line of thinking that I presented to you, so you may use it. So for example, day of the week will affect air pollution because during the weekends we expect less, during the week we expect more. For example, temperature will also affect air pollution because if we have low temperatures, people will use more heating. Some cities have heating on solid fuel, not electricity, and so on. So you can try to rationalize why the different parameters matter in a different way. So this is a thought example. So I don't think there are wrong answers. Just try to rationalize it. And finally, provide your thought on the application. Do you see possibility to develop it further? What else should be included? Can you think of an example for commercialization? This is again to you, so you just can give your own opinion or some thoughts on this. So it's not specifically something that I can explain. So it's something that you may that you want to provide as a view or as a how do you see it. So this is basically assignment 1. So because we are a lot ahead of time, I think we took a little bit more time for this. I directly go to Professor Fergan. So if you have any questions, just interrupt and ask or write in chat, so no problem with that. If you figure some question on my assignment, you can still ask it, but now I give it the word to Fergan. So he'll proceed with assignment number 2.
Yes, so greetings. As I was presented, my name is Fergan Feradov, and I designed the assignment 2. I will try to present it as quickly as possible by again covering first of all the idea behind it, the main goals, and then what each task aims and what do you have to accomplish. And the tasks are relatively simple, but we will go through them. The idea, first of all, the topic is data classification and feature analysis using Weka machine learning toolbox. So the idea behind this task is that not everyone, as it was pointed out in the chat, has very deep knowledge of math and the details about classification and algorithms, classification and, for example, feature selection algorithms and so on. Actually, all these algorithms in machine learning are very highly specialized, and they're developed by experienced and trained mathematicians. So it is often very hard, let's say, to get into them or try to analyze them. But sometimes people from different fields need to use them. And the fact that you need to use them doesn't mean that you have to know the nuts and bolts that go into each and every algorithm. And there are many tools, as Professor Marinov pointed out. Python has toolboxes that provide easy access to the algorithms, and Weka is one such toolbox that allows us to use the algorithms already developed and integrated for our tasks. And this was again the main goal, to see and get a feel about how to use different algorithms and what each algorithm does and use it to analyze features, again, without going into into the very core of what and how what each algorithm does mathematically and how does it work. So the tasks are aimed toward analysis of features, which is something that can accompany or is actually a part of every machine learning task. The features are a core element of classification. It is actually the parameters that we use to differentiate one thing from another. And in many cases, it is important for us to know which features are important and which are not important. And I always give a very simple example. If we try to differentiate cat from dog, a feature is the number of legs is a feature. Does it have a tail or no is a feature. What does it eat? Does it eat fish or bones, let's say, or meat is a feature? Or if we have a genetic test of that animal and we have the score and genetic parameters that the test gives, that's also a feature. And you can, as you can imagine, from these four things that I just mentioned, some are completely useless, like the number of legs won't help us differentiate cats from dogs very much, but the results from a DNA test will pretty much render all other features useless. We don't need to calculate or have them. And this is such analysis of the features and differentiation can be made for each task. So that is what we aim in the assignment to see how feature analysis is carried out. Again, Veka is freely distributed. I have provided both a small explanation of how to use it and how to download it. And I will go very fast through these details. So when you run and you download Veka, this is the window that you get. And we use the Explorer application. And in the Explorer application, from here, we can open a file that we have selected. And I have provided a big data assignment to dataset, which contains information about the GDP of each European Union member. And the European Union members or countries are separated based on their GDP in two classes, high GDP and low GDP. And the threshold is $30,000 per person, or $30,000 GDP. So that the data covers the year, includes 6 features, or more correctly, 5 features for the period from the years 2000 to 2020. And the 5 features are greenhouse gas emissions, material consumption, material production, pollution effect, and protected area. So, and you can see how classes A and B are different in regards to each of these features. So once the data is loaded, we can already see the features and the distribution of the data. So I will go, you can check more detail, in more detail, the explanation for the fields. And I will give an example for the classification. And from there on, I will explain each task. So how to classify the countries, again, based on their GDP, using this tool. So we go to the Classify tab. And from here, we can choose a classifier. And again, Veka has a number of classifiers imported inside of it, and we can just use them as how should I just say, as a ready tool. And if we are, of course, interested in it, it is always important to know at least relatively what the algorithm does. But if I just want to use them as tools and all I know is the name, I can do that. And for example, Professor Marinov spoke about decision trees. And here we have different types of decision trees. And I will use J48 algorithm, which is a type of a decision tree. So once I select the algorithm, I just say classify, and the software classifies, solves the task and classifies the two classes A and B, depending on the features that I have given. And here you can see the correctly classified instances. And this is the total accuracy achieved by the certain algorithm. And you have other parameters which are used to evaluate the accuracy. And also we have a confusion matrix, which shows us number of correct for A and wrong classifications for A, a number of correct for B and wrong classifications for B. And we can, again, perform this classification using a number of different algorithms. Again, I used K nearest neighbors, which is another algorithm. And here I can see the accuracy of that algorithm on the same data. So this is actually the first task that you have to solve. I have pointed out or highlighted 5 different algorithms, and you can run the classification task and see how each of the algorithms behaves when, or at least compare their accuracy. The second task now aims towards the evaluation of the importance of each feature that I have given. And again, the features are greenhouse gases, air pollution, protected areas, material consumption, and material productivity. So we go to this time select attributes tab. We choose, and I have chosen the relief F attribute evaluation. And as you can see, there are a number of different ranking algorithms. And if you're interested, you can try out and compare them. But for the task, you will need to use the relief F. And once you start it, it ranks the features regarding their importance. Now, again, here you can run it a couple of times. And if I run it 3 times, you will see that each time the result is the same. And the ranking of the features is the same. So as we previously discussed, here we have an algorithm that's deterministic. So it will, for the same input, it will always give the same score. And this was different from the ranking that you performed in assignment 1. So here you just write down which of the, how are the features ranked, which is most important and which is least important. And then from then on, we can see how they affect classification. So in task 3, we repeat the classification process. But if I come back to the first I will check, and it says that material production is the most informative feature in regards to GDP. So the number of produced materials per each country is most closely related to its GDP or the separation based on GDP. So this has, again, it is logical. And if I return to the pre-process or my first window, and I select materials produced, I can remove this. I can remove this feature and repeat the classification without it. And I will again use the k nearest neighbor, and you see it was affected from 99.25%. It dropped to 99.07. So the accuracy dropped, but still it is almost negligible, the drop of accuracy. But here you can perform the test by reducing the features each time, and you will see how the accuracy drops with each feature that we remove. And you will see how each feature affects the accuracy. So at one point, again, I removed only this feature, but the others are still informative enough for us not to lose a great amount of accuracy. But you will see as you drop features, you first remove information. So the classification becomes even harder when you have less information. And then you are performing the classification with less informative features. So you will see how the accuracy will drop. And in table 4, you can actually, what table 4 requires you is to calculate the drop-off in accuracy for each removed feature. And task 5 requires the comparison using one feature, and that feature is only the highest ranked and the lowest ranked feature. And to calculate the difference in accuracy in the quality. So the difference in accuracy here that you get as result difference will actually be the difference in the quality between the highest rated feature and the lowest rated feature. So in this way, you can see not only how each feature affects your classification, but how using the correct features affects your classification. So this is also, again, aimed solely towards analysis of feature classification and analysis of the importance of features, and through the use of already produced and readily provided tools. So you don't have to write the algorithm, you don't have to write the code. You have the tool and you just use it for once. This is just an example. If you have another task with other features in the field of economics, biology, and geology, you can, whatever field you name, you can use this tool as a professional in that field to solve classification tasks. And again, without a very vast or prior knowledge in the machine learning and algorithms and math. So that is the primary focus. And task 5 is again based on the observations. You can write what are your conclusions on the effects of the feature. So what you have seen, you can explain it. And again, as Professor Marunov said, there are no wrong answers here. It is all based on how you have perceived and understood the exercise. And pretty much that's the assignment, its goals, and details about the tasks, each of the tasks. So if you have any questions, feel free to ask them and I can answer you. If not now, maybe I think I have provided my email. So while solving the tasks, you can always contact me for help regarding the tasks. Thank you. So
Super. Thank you very much. This is great. I don't know if there is anyone from the student has questions. You know, you can at any time you can send us using my email, using maybe WhatsApp group or so. If there is anything that's not clear, we ready just to help you at any time. So we can make another session. Maybe you can exchange email with you. So hopefully this will be useful. So just waiting to anyone has any question?
No, I don't have a question. I just wanted to say, hey, I just wanted to say thank you that you're recording, because I'll have to go through it again step by step.
No problem.
And digest it, because this is the first time I'm ever doing anything with algorithms. So it's good it's being recorded. Thank you very much.
No problem. You're welcome.
and also the information was a lot for the small period that we had. So yeah,
that's why I was saying to record, because I think the information will be too much, the short time. Maybe like Mariam, for example, first time to use, maybe people who are not here. So this is good to have this record to review it.
And again, the tasks are aimed exactly at such first-time users that might need these algorithms, because they are required in many fields, and with passing of time, they're even more required with each day. But there is no need for each and every one to understand the math behind it, because again, it's very complicated, but can use the tools to solve problems in any specific field.
Yep, great. So if there is no question, maybe I conclude the session. Sorry, I was not with you most of the time. I was in another meeting, but now I came. So I will conclude the session. Maybe I can ask our colleagues, the student, to leave the session, and then we will have another short meeting with the professors.
Okay. Thank you to everyone. Have a nice day. Thank you.
Thank you. Yep.
So
I'm not a good student. I became so sleepy during graduation.
No, but I think maybe I can stop the record. How we can stop the record?
This was
No problem.